Hi everyone, in this session we are going to discuss CBSE Class 9 Chapter 2 Science, that is matter around us pure? In the first chapter, matter in our surroundings, we discussed each and every point very clearly along with daily life activities, right? So, in this lesson, is matter around us pure? You have to know first of all what is pure. So, in general language, what we say, if any substance which doesn't have any impurities, that is called pure, right? But when you define a material or a substance, purity is different here than what it is. Okay. Before going to this, consider any consumable things like salt, daily life consumable things, milk, any product from the supermarket you have seen, they are labeled like 100% natural, 100% gear or pure. So they labeled like that. But is it reliable? No. Why? Because in the pure ghee, it is labeled as pure ghee, no, but they have added some additives, some preservatives, some coloring reagents, like that. In any object or any consumable thing, they are saying that 100% natural and pure, but they don't, because they do have some kind of substances as well. Okay, but they are not contaminations here, other substances. Okay, so now coming to the definition point, deeper into substance, pure substance. What is pure substance? A substance that contain same type of particles. This is the simplest definition you can remember very easily. Substance that contain same type of particles. Okay, all the constituent particles of the pure substance are in same in their chemical nature. Then what is this chemical nature? Like their boiling point, okay, their effects on pressure, by applying pressure or temperature, they have undergo some changes, right? So every particle in a pure substance has the same chemical nature, okay, same type of particles, that is called pure substance here. Okay, next, in our surroundings, generally matter can exist in different forms. Like when you observe your surroundings, matter is exist in different forms, no, not like in solid, liquid and gases, not in that sense. So here when you go deeper, so elements, compounds, mixtures. Okay, what is element, what is compound, what is mixture? From the pure substance you have to know what these are, then you have to go to another concept. What is element? Element is nothing but which is made up of one type of atoms. Okay, that means same type of atoms. All the atoms in element has same number of protons. Okay, any element, any element from the periodic table you can take. Okay, it cannot be broken into simpler substance by chemical reactions. So not seeing this definition, just come into the example, daily life example. So examples are sodium, fluorine, any element, gold, silver, chlorine. So element can be metalloid, metal, non-metal, gas or anything, right? So suppose take gold here. So in gold, what you have, so why I displayed this picture only? Because when you take ornament, it has some other substances like copper and silver, right? But when you take the 24 gold like biscuit, you have only gold atoms throughout the substance. When you take this point, when you take this point, when you cut this point, all the sides, any part of this substance has only one type of atoms, that is gold. Okay, and each any atom has same number of proton, because all the atoms are one, that is all. In the same way here observe the difference. Here 24 carat gold biscuit is the pure element, but gold ornament is the not pure substance, right? In the same way, carbon, diamond, which has only carbon atoms in this, right? In the same way, gold. In the same way, if you have taken any oxygen cylinder, it has only oxygen gas in that. That is pure substance or the element, you can say. This is the only element in the oxygen cylinder. In the same way, nitrogen cylinder, you have only nitrogen gas in that. Okay, wherever you have taken the sample, it represents only one molecule or one atom or one particle. Okay, simply you can say atoms. So that is called element. Then what is compound? So I ordered like this because each and everything, element, compounds are interrelated. That's why I have written like this. See, what are compounds? compounds are formed by the combination of these elements in a fixed ratio by chemical bonding. What is compound? So you have only different elements, no? Not like these substances. In the periodic table, you have more than 118 or 120 elements, right? Each two or three elements can combine in a fixed ratios by different chemical bondings to give you numerous compounds. Like you can say there are infinity possibility of infinity compounds they can form from the elements, right? So the elements to combines in a chemical bonding in a fixed ratio. So what it is, we'll see. Example, daily life, again, baking soda, sodium chloride, salt, baking soda, water, ammonia, right? So this is salt, this is table salt, you can say. So I'm saying this is compound and this is combined by chemical bonding in a fixed ratio. What it is, let's see. Sodium chloride. So here sodium is one element, chloride is one element, right? These two elements combined, how they combined? In a fixed ratio. That means one sodium atom attached with one chlorine atom. Okay, this is called fixed ratio by chemical bonding. Chemical bondings are also so many different types: ionic, covalent, coordination. So in this case, sodium and chloride, through the electrostatic forces or the intermolecular forces, they have combined like a to form NaCl. Okay, in a fixed ratio means this one. Okay, chemical bonding means anything between these by sharing electrons, by sharing the forces, by right, they will form the compound. Another way, NaHCO3. In this also, what you have? Sodium one element, hydrogen element one element, carbon and three oxygens. These are combined. These elements, each element, right? These elements are combined in a fixed ratio. Okay, by chemical bonding to give you baking soda, that is sodium bicarbonate here. So these compounds can be gases, liquids or solids. Okay, this is solid, you can say. This is also solid, but in HCl at room temperature, HCl it is a liquid. So HCl again, H one element, chloride one element, 1:1 ratio, they form compound, right? In the ammonia as well, ammonia, nitrogen is one element and hydrogen one element, they formed in a 1:3 ratio. This is fixed ratio, this is 1:1 ratio. So in this way you can have ultimate number of compounds formed from the combination of elements. Okay, this is called compounds. Then so next concept is mixture. Material composed of two or more substances. We discussed earlier, no? Compounds and elements. When you combine two to three or four compounds or elements, the obtained material is said to be mixture here. Okay. So based on the consistent compound type, whatever the compounds you are adding, you are combining, based on that type of that compound, mixtures are two types. That is homogeneous mixtures and heterogeneous mixtures. And homogeneous mixtures, what is homogeneous mixture? When same kind of compounds are mixed together, they'll give you a clear solution if it is liquid. Okay, so when they diffuse one to each other and they combine very conveniently, then it will give you the homogeneous mixture. So I'll explain you with the daily life activity. Take a glass of water, this is water, then add 1 spoon of sugar and 1 spoon of salt. Okay, when you add 2 spoons to this water and mix it well, what you will get very clear solution, right? So that is uniform composition. You don't observe any layers or any puddles in this, right? So that's you will get uniform composition. When your mixture gives you uniform composition and a clear solution, that is called homogeneous mixture. Okay, so this is the daily life example, you can say. And the homogeneous mixture can be of variable composition. Simply you can say salt is 1 spoon and sugar is 1 spoon. No, not like that. You can add 2 spoons, 1.5 spoon. So the variability of composition also happen in homogeneous mixtures. What about heterogeneous mixture? Take a glass of water, then add 1 spatula of sand or soil, then oil drops. So what will you observe? The sand will settle down at the bottom of the glass and the oil drops layered on the top of the water, right? This is called uniform, non-uniform composition. That means you'll observe physically distinct layers. physically distinct parts, you can say distinct layers, you can say. When you observe physically distinct layers or distinct parts in that your mixture, that is said to be heterogeneous mixture. I am trying to tell you with the daily life activities, you can find the fine definitions of these things in anywhere, right? But understand the concept or apply the concept to the daily life, it will be very easy to understand and write as well. Okay, this is about homogeneous mixtures and heterogeneous mixtures. Then in textbook there is an activity given. What is that? In lab, that simple thing you can observe in a laboratory. Take a water with a beaker, okay, sorry, beaker with water, and add 1 spatula or 5 grams of copper sulfate crystals. I clearly showed in the last videos how the copper sulfate crystals will be. And add another beaker with water, add double amount or double spatula of copper sulfate crystals. What will you observe? You will get the clear solution here, the light blue and the dark blue, but you will get the homogeneous solution here, no layers, no distinct parts, right? So this is called the homogeneous solution, and this is uniform composition. What about this thing? So you can observe in lab as well. When you add sulfur and iron is like in a laboratory you'll have zinc dust, iron fillings, or iron dust, zinc dust, this kind of things you'll have. Okay, when your teacher showed, you'll know. So sulfur and iron look like this. Okay, so oil and water, you already know this. And iron filling, salt and sand. Simple. Sand is here SiO2, silica. Salt is NaCl crystal type of things. Iron is a metal. So all things are different nature, right? This is non-homogeneous, non-uniform, you can say. So these are called heterogeneous mixtures. So in the daily life, in the food also, we can find most of the things around us are heterogeneous mixtures only, like pizza, like biscuits. So different kinds of things are subjected and mixture, they make into mixture and they'll give you a nice product. Okay, so this is about homogeneous and heterogeneous mixtures. Let's see this activity. Okay, when you go to lab, your friends and you people divide into 4 groups: group A, group B, group C, and group D. So the instructor has given you one beaker with 100 ml of water to all groups, right? Then they provided with 1 spatula of copper sulfate to group A, 2 spatula of copper sulfate crystals to group B, and chalk powder, or you can take a wheat flour in this place to the group C, and 10 ml of milk to the group D. So they have to do or dissolve these crystals in this beakers, this chalk powder in this beaker of water, and milk in this glass of water. Okay, so when you observe, the 1 spatula of copper sulfate crystals will dissolve very easily and you will get a clear solution, as well as the 2 spatula copper sulfate crystals will also dissolve. So you can use the glass rod to make it a clear solution. Okay, here all the beakers in all beakers you have to use the glass rod to mix the contents. You can take the group C has taken chalk powder. No, initially it looked like it is dissolving, but when you put it after aside for some time, like half an hour, the particles, whatever you have dissolved, the chalk powder particles will settle down the bottom of the beaker. In group D, you very well known thing that is, you will get a white mist type of solution. Okay, so this is the activity. The observations are, what are the observations here? First you have to mix the contents either with the glass rod. Okay, so then you have to set aside for a few minutes, then you have to observe. Okay, you will get the clear solution here and here, right? So this is called solution, clear solution, you can say. So you can confirm, you can confirm how it is clear. So by the Tyndall effect, which is a later on concept, but you can observe the last observation. You can the torchlight, have a torchlight and you'll have the beam, right? So observe this light, this beam. Are you observing this path? Is this path displayed here, or you can see this path of light here? If you can see, that is a clear solution. Okay, the light is not scattering here, light is passing through the beaker, through the solution. That's why you can see the path of light here. That is okay, so that's called solution, clear solution. In this also you can see the light beam. Okay, in the chalk powder itself, when they settle down, no, this settle down material, this type of solution is called suspension. Suspension. Okay, it's look like it dissolve, but after some time you settle down at the bottom. Then you also observe this thing to this solution as well, the beam light experiment. Okay, for the milk also, you at the home, you can easily observe when you put on torch on milk glass. Have you seen the path to through this or up to this one? Filtration. This is how filtration looks in a laboratory. What is filtration? So whatever you mixed up in beakers, the last observation you have to do is you got clear solution, you got the suspension, you got the colloidal solution, right? So you have to filter all the solutions here to observe is there any you can get any residue or not. So you have in laboratory that is called Wattman filter paper, which is in round shape, and you have to fold it in this way, like in this way. So you'll get the it is suitable to fit in a funnel. This is funnel. I'm showing you the real pictures for every lesson as well. So here the real Wattman filter papers are here, and these filter papers are folded in such way that it can fit into this funnel. Then pour the contents you have prepared, the mixtures you can filter in this way. So this is the setup, the beaker containing the mixture. Okay, so filter paper, the funnel, then this is the conical flask. Okay, so this is filtrate. What is filtrate? I'll tell you. So the remaining part after the residue has taken out, that is called filtrate. Okay, here the residue, if you filtered the clear solution, the HCSO4 solution, what will you get? You didn't get anything because it is a clear solution. For first A and B people, groups A and B didn't get anything, right? Residue. After that, the suspension thing, right? The chalk powder mixture, group C will get the residue here. The chalk powder, the residue here. Okay, you filter the once the residue filtered here, the remaining solution will come under this conical flask. No, that is what called filtrate. Okay, next the group D has suspension milk. If you filter milk, what will you get? You didn't get anything. The direct milk will come to this conical flask, right? So these four observations, the four groups has to do in the laboratory to observe what kind of mixes you are mixing, what kind of solutions you are getting. Okay, the next concept is solution. Solution is nothing but homogeneous mixture of two or more substances. These two or more substances can be solid, liquids and gases as well. Usually we think like that if it is a solution that should be in a liquid format. No, in a daily life we are seeing so many examples of solid solutions and gaseous solutions as well. Okay, so it is a property, main property of the solution is it has the homogeneity at the particle level. That means when you have taken any particle, it shows the same nature as the whole object. Okay, so the very simple example of a liquid solution is like sugar syrup, right? Sugar is added to or salt is added to water, and it will give you the clear solution, that is liquid solution. What is solid solution? Alloys. In daily life we are seeing this, right? Gold ornaments, which is a combination of metals, gold, copper, silver in different proportions. In the same way, what is alloy here? Alloy is nothing but a combination of metals or non-metals. Metals, a combination of two or three metals, or no, combination of metals and non-metal as well. So the best example is cast iron, in which iron is metal and carbon is non-metal, right? In daily life you're watching these things, right? And sterling silver, not sterling silver, any silver you can take. Even our utensils, steel utensils, it is also the combination of different metals. Bronze, in the temples you have the cultures and bells, no? So brass, these all things are solid solutions, but this is the only example level. Only in the ninth section only examples are given, but the details should be explained for the liquid solutions as well. Okay, here the gaseous solutions you're seeing every day in air. You have carbon dioxide, oxygen, nitrogen, hydrogen, so many gases, right? This is also gaseous solution, right? We have to focus on liquid solutions. Then it is the best example, right? If you are taking 1 spoon of sugar and add it to 1 glass of water, here it is termed as solute particle or solute, in which you are adding is called solvent. Okay, the obtained mixture is called solution, right? Here, what is solute? Sugar, sugar particle. What is solvent here? Water. In water, sugar is added, no? So this mixture is called solution. The solute which is to be dissolved, the substance which is to be dissolved is called solute. The substance in which it is dissolved is called solvent. The obtained mixture is called solution. Okay, these 3 points you have to remember always in your mind. Then coming to the detail point, I'm telling you the solute is dissolved in this. How about this solute? This solute may not be liquid all the time. It can be liquid, it can be solid, it can be gas. Here we discuss the example solid in solvent, right? That is, what is the example for this? Solid in liquid example, like best example, salt or sugar or copper sulfate or iodine, which is known as a tincture. These, when these are dissolved in water, this is the example for solid in liquid solution, right? So another example, liquid, best example, alcohol in water. That is liquid, 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 liquid. Another example, gas, oxygen dissolved in water. In our daily life we can see. And aerated drinks in which carbon dioxide is dissolved in the drink, right? So intention is here, the solute may be in the form of solid, liquid or gas. The solvent here is liquid. In your syllabus this is given, and the strength of the solution also we have to calculate. In that sense, how much liquid you are adding, how much solid you are adding, how much gases particles you are adding, and what is the strength or the concentration of the liquid. These things we have to go further. Okay, here the solute can be in 3 forms, right? Next concept, types of solution. Based on what? What is the criteria? Based on the amount of solute present in it. We discussed earlier, no? Some amount of solute is dissolved in solvent. That what is that amount? Based on that amount, the solutions are labeled like concentrated, unsaturated, and saturated solution. Okay, these definitions will be well understood after explaining this activity, simple activity. Again, take sugar. Okay, take 3 glasses of water or 4 glasses of water. So when you dissolve just 2 to 3 crystals to this water, like this can be like 100 ml or 200 ml. Okay, I'm not saying here the measurements, because I'm telling you the definitions of these 3 solutions, types of solutions. When we calculate the concentration of solution, will tell you the, I'll tell you the measurements. Okay, some amount of water, it can be 100 ml, then add 2 pinches of sugar. So what will you notice? You didn't notice that much of sweetness in that solution, right? So the very less amount of sugar is added to water, 100 ml of water. Then what it is called? That is called dilute solution of sugar. Okay, why? Because the solute is very less. Okay, if you add 2 spoons, 2 spoons sugar to this water, what it will do? It will dissolve the solvent. The solvent here is water, right? The solvent dissolves the 2 spoons of sugar. Then you can notice good sweetness, right? That is called concentrated solution. Concentrated solution, right? Then you can add some more spoons. Up to what position? Here water will tell you, so I can dissolve more spoons of sugar. You can add in that way, it can sense, right? Then you can add 2 to 4 or 4 spoons, like, then it will dissolve. It will dissolve and gives you the clear solution. Then what it is called? Unsaturated solution. Unsaturated, it means it has more capacity to dissolve sugar in water in it, right? Unsaturated, it is not saturated, it has more capacity. Say, come on, how many spoons you can, I can dissolve in that way. Okay, so at one point what happened, you are going to add some more spoons, like sixth spoon or eighth spoon. So when you add, at some point there is a one level that this water cannot dissolve 1 crystal of sugar anymore. Okay, then that state is called saturated solution. Saturated, it is saturated. Okay, so a simple example in daily life, you go to pani puri wala, no, you get one or two pani puri or three or four pani puri, it is concentrated stomach. Then you want to eat more. I can eat some more pani puri, that is called unsaturated. So at one point you cannot eat even single puri, then that is called saturated. Okay, so this is the concentrated, unsaturated, saturated. When you come to the definition in chemistry, what is unsaturated solution? If the amount of solute is less than saturation level. So this saturation level is the point where there is no the dissolution happened, that is called saturation. No, before that position less than that saturation level is called unsaturated solution. What is saturated solution? When no more solute, what is solute here? Sugar. No more solute can be dissolved in solution, that is called saturated solution. Okay, I got it. The amount of solute is less than saturation level is unsaturated solution, and the saturated solution is nothing but no more dissolution happens. Okay, so we are saying that saturation, no, saturated solution. So at one point at room temperature or a given temperature, at this point at that temperature, the amount of the solute in the solution is called its solubility. Suppose if you are taking 100 ml of water, okay, I am adding 5 spoons. At 5 spoons, it cannot dissolve another more. Okay, so at this temperature, this amount of solute is dissolved in this water, right? So that is called the solubility of the solute, the solubility capacity in 100 ml water, how much it can be dissolved, more or less 5 spoons. For example, I'm saying, so that capacity is called the solubility of the solute in given solution, like solvent, given solvent you can say better. Okay, yeah, we discussed saturated solution, unsaturated solution, and the solubility and concentrated solution. Okay, so now how to calculate the strength or the concentrated solution strength, you can say concentration of the solution. Okay, right. Next concept, the concentration or the strength of the solution. How it is measured? What is the concentration or the strength of the solution in terms of amount of solute? That means the amount of solute present in given amount of solution. Amount of solute, it can be expressed in mass or volume, as well as the solution, it can be expressed in mass or volume. Okay, let us discuss with some example. Suppose I have taken a beaker with 150 ml of water here. 150 ml of water. What is water here? Solvent, right? Solvent. Okay, then I have taken 10 grams of salt, 10 grams of salt to dissolve in it. Okay, what is salt here? Solute. Okay, what happened? 10 grams of salt will dissolve in 150 ml of solvent, which will give you the salt water, nothing but solution, right? This is called solution. In the solution, you have now 10 grams of salt plus 150 ml of water, right? Yeah. So why I am writing this, you will notice. While expressing, till today, we are explaining like one spoon or one spatula of the solute, right? But for the sake of calculations, we have to express in terms of units. That's why there are some formulas in expressing the concentration of any solution. Here, three ways: mass by mass percentage solution, mass by volume percentage of solution, volume by volume percentage of solution. How it can be calculated for this solution? Here, the formula is mass of solute divided by mass of solute plus mass of solvent. Why? Because in the solution we have both solute and solvent right here. So in some books it is directly written like mass of solute divided by mass of a solution. Okay, solution directly they have written. So in this, what is the into 100? In this, mass of solute is 10 grams divided by mass of solute again 10 plus mass of solvent water, that is 150 ml here, right? So when you expressed in grams, 150 ml equal to 150 grams, then 1 ml equal to 1 gram, right? That's why 150 grams. So 10 by 160 into 100. It is the mass by mass percentage of solution. In the same way, mass by volume. Mass of solute divided by volume. Volume of solution. Again 10 by 160 you will get. Okay, so in the same way, volume by volume. Here, volume of solute. For the solid particles, the solid solutes, you may not apply this one. For the volume, right? You can take examples like 10 ml of masa mixed in 100 ml of water, 150 ml of water, or 15 ml of alcohol mixed in 150 ml of this one. Any liquid. Solute can be liquid. In that sense, you can use this formula, volume of solute divided by volume of solution, okay, into 100. In this way you can calculate the concentration or the strength of the solution in 3 ways. Okay, we will discuss with the given one numerical in textbook. That is, a solution contains 40 grams of common salt, 320 grams of water. Calculate the concentration in terms of mass by mass percentage of the solution. Okay, here what is solute? Salt. Salt equal to solute, right? Solute mass equal to 40 grams already given. Then what is solvent here? Water, right? Water equal to solvent here. Solvent equal to mass of solvent is given in mass, right? In grams, not in ml. Anyways, it is the same, 320 grams. Now, what is solution here now? Solute plus solvent, right? Then mass of solution will be 40 plus 320, that is equal to 360 grams. This is the solution, mass of solution, right? So formula is, what is the percentage? Mass by mass percentage. So mass of solute divided by mass of solution. We have both values, right? Into 100 equal to mass of solute is 40 grams. 40 divided by mass of solution is already calculated, 360. 320 plus 40, 360 into 100, which will give you 11.1%. So in this way you can calculate mass by mass percentage of the solution, right?